In today's video, we are going to see what is the relation between generator matrix and parity check matrix in case of linear block codes. Generally, we have to obtain parity check matrix from the generator matrix. So there are many confusions about the dimensions, about IK matrix, about the dimensions of P matrix. So not needed to remember all those dimensions. Here I'm going to tell you the few 2 to 3 points. A few, I can say 2 to 3 points that you have to remember, so that you can build the generator and the parity check matrix. Generator matrix already they give in the example, uh, uh, and you have to obtain the parity check matrix. So first you have to concentrate on the code dimension. So LBC code here is 7,4. So n is 7, that means number of bits in code are 7. K is 4. Out of the 7 bits, k bits are message bits and parity bits are 3. 3 is obtained by 7 minus 4, that means P is equal to n minus k. Now generator matrix dimensions are number of rows are 4 and the columns are 7. So what you have to do, 7 comma 4, you have to write it as 4 into 7. So easy to remember, 7 comma 4, 4 into 7. That means there are 4 rows and 7 columns. Then first is a identity matrix of dimension k in the generator matrix. So this is one form of generator matrix where you are going to get the systematic code. So IK you have to remember, that means you have to write here the k dimensional identity matrix 1 0 0 0 1 0 0 0 0 1 0 0 0 1. After that, the remaining 3 columns are of the parity bits. So here these combinations they give in the form of equations or they directly give you the generator matrix. So here are the parity bits combinations. So here you get the parity bits from these combinations. So this is the format of the generator matrix. Now you have to find the parity check matrix H, which is used at the receiver side to decode the received code. So you have to first see what could be the dimensions of H. H dimension would be 3 into 7. So 3 you have taken from here. Parity bits, number of parity bits are 3, so 3 into 7. Columns are same in both case. Here the rows are 4, here the rows are 3. So first step is that you have to just take the transpose of this P matrix. So transpose means this row you have to mold it vertically, or you have to write it as vertically. So 1 1 0 0 1 1 you have to write it as vertically, 0 1 1 triple 1 vertically you have written here, 101 vertically you have written here. That's it. So you obtain the transpose of P. Now 4 columns are completed, remaining are 3. 3 columns are remaining. There you get you have to write the identity matrix of dimension P. So what is P? P is 3. So identity matrix of dimension 3. So 3 by 3 identity matrix is there. So it is very easy. 7 comma 4 generator matrix dimension 4 into 7. First is IK, then P. Then H matrix, the dimensions are 3 into 7, that means P into N. You have to take the transpose and the remaining is identity matrix, but it is of dimension P, that means 3. Let us take one example of 6 comma 3. So LBC 6 by 3, 6 comma 3, so N is 6, K is 3, P is N minus K, that is 3. So generator matrix dimension are K into N, that is 3 into 6. So the first IK means 3 by 3 identity matrix. Next this P is, they will give in the exam, or they will give the equations for this. So this is P matrix. In H the dimensions are P into N, so 3 into 6. So the first is PT is, you have to write 101 vertically, then 011 vertically, 110 vertically. After that there is a identity matrix of dimension P. P is 3. So identity matrix of dimension P. So the main important points you have to remember: 7 comma 4, 4 into 7, 3 into 7, then IKP and PTIP. So I think it is sufficient to remember these 3 points to obtain the parity check matrix from the generator matrix.